Hi everyone, Miss Andronicus here, and today we're looking at multiplication and division of fractions. So starting off with a bit of terminology, an integer is a whole number, a fraction of course, part of a whole, okay? So that's what we're talking about when we are looking at multiplying or dividing an integer by a fraction. So I'm just going to launch straight into the examples so that you can have a look step by step with what we're doing, because it's very straightforward with multiplying and dividing. So the first example, you've got 8 multiplied by 4 over 5, okay? With multiplying and dividing, it's top multiplied by top, bottom multiplied by bottom. Or, as we know the terminology, numerator multiplied by numerator and denominator by denominator. Having a look at example number 1, the first number is an integer, so it doesn't necessarily have a denominator, and the second is a fraction. But have a look at this green box over at this side. If you have a whole number and need to calculate it with a fraction, put it over 1. So I can add a denominator of just 1. Okay, so now we have numerators and denominators, and it's just top by top, bottom by bottom, simple as that. So you've just got 8 multiplied by 4, 32. 1 multiplied by 5 is 5. No worries about any sort of same denominator, nothing like that, just straight into top times top, bottom times bottom. Of course, you need to rework that. So we've got how many 5s go into 32? 6 wholes and 2/5 left over. As always, we'd need to check if we could simplify that at all. Okay, I'm going to keep going with the multiplication and I'll circle back to division in a moment with example number 2. Okay, now we have a mixed fraction in this example. We've got a mixed fraction, so here this rule applies. Always make mixed fractions completely improper before multiplying or dividing. This is very, very important. You cannot proceed without doing that. So that's the first thing I need to do. 2 multiplied by 3 is 6, plus 2 makes 8 over 3, multiplied by, and I do the same process, 6 over 5. Okay, so now we have a top and top, bottom and bottom, same rules apply. So we do 8 multiplied by 6 is 48 over 15, and of course regrouping 3 and 3 over 15, and last but not least simplifying, because we always need to check. We've got a 3 and a 5, 15, both are divisible by 3, so it's 3 and 1 over 5. Okay, now I actually show you a little bit of a shortcut. As you saw, there was quite a few steps, and of course there was always that simplifying in the end from this step to this step. What you can actually do, if I take that across and we have 8 over 3 and 6 over 5, there's a simplifying method that you can do really easily at this stage, and it's called cross-simplifying, or sometimes it's known as the bow method as well. And you actually have to look diagonally. See how I've drawn those arrows? So you look at the 8 and look at the 5 and say, is there a common factor? The answer to that is no. Look at the 6 and look at the 3. Is there a common factor there? The answer actually is yes. And what is that common factor? Both of those numbers are divisible by 3. Okay, so 3 divided by 3 is 1, 6 divided by 3 is 2, and that's our new numerator and denominator in those positions. So it actually then becomes 8 over 1 multiplied by 2 over 5. Much easier numbers, much easier calculations, and top by top, bottom times bottom. So it becomes 16 over 5, and then straight to 3 and 1 over 5. See how we skipped all of these larger numbers in here and went straight to that answer down there. See that? So you still get to the same answer much faster because you cross simplify at this point. Very, very handy when you have large denominators which end up having large numerators when of course you need to then make it improper. So very important that you cross simplify. Okay, very important. So remember that method even when it comes to division. Okay, so I'm going to do the quick division explanation for dividing an integer by a fraction or even fractions by fractions. So with this, you still need to put it over 1. So that first step applies when you put 8 over 1. But now the next stage is this. You look at the second fraction of the division. Always the second fraction. I can't stress that enough. Must be the second fraction. Okay? Very important. The reason why I'm saying that is because otherwise it will not work. Okay? So you take that second fraction and you literally flip it upside down. So it ends up being 5 over 4. I'm just going to line this up nicely. See how I've literally just turned it upside down. 5 over 4. Because you've made that upside down, it actually turns the division into a multiplication. So this act of turning that fraction upside down is actually called the reciprocal. Reciprocal, okay? The reciprocal. Very important that you remember that term, okay? Once you get it to this stage, then you can do exactly what we mentioned below, which was cross-simplify. So the rules for normal multiplication now apply. You've made the reciprocal, it's become multiplication, so all of that still applies. So I can look diagonally and immediately I can see that the 8 and the 4 are both divisible by 4. So that becomes a 2, that becomes a 1. Now my new fraction, 2 times 5 is 10, 1 times 4 is 4. That becomes 2 and 2 eighths, and I'm running out of space. 1 and 1/4, because remember you need to always simplify in the end, okay? Very important. Okay, lots of exciting maths going on. The last division, last thing that we do, absolutely that same step applies, making everything improper, and it's still division 6 over 5. Remember, we always take the second fraction, we flip it, get the reciprocal, 8 over 3 multiplied by 5 over 6, and we cross simplify where possible, okay? So the 8 and the 6 can be simplified. Both are divisible immediately, I can see, by 2. So that becomes a 3, that becomes a 4 because I've divided by 2. And then it's 4 times 5 is 20. 3 times 3 is 9. So you get 2 wholes with 2/9 left over. That's as simple as it can go. Thanks, guys.